Okay, project management students, today we're going to be talking about critical path analysis and float. We're going to spend a little extra time in chapter 6 talking about what critical path actually is and what the concept of float is. What these concepts all encircle are the idea of time management. How much time do you need to spend on a project? What is the absolute minimum or maximum amount of time you should take to accomplish a project? And what is the critical path? Now, we spent some time using project management software, but the purpose of this assignment is to really show you how to do this stuff manually. If you wanted to figure it out, how do the calculations actually work? How do you determine what the critical path is and what activities have wiggle room or float? So why is this stuff so important? When we look at the three constructs of project management, we're talking about scope, cost, and time. You can always change the scope. You can make a project bigger or smaller. You can always add more resources, hopefully, if you've got management that's got cash reserves, for example. Time is a finite construct, and of the three, it's sometimes the most difficult to manage because you can't create more time like you can create more funds or more resources for a project. So this is also a concept that shows up a lot in PMP exams if you're interested in pursuing a project management certification. That's why we spent a little bit of extra time on it here. So what is the critical path? The critical path is one of the most misunderstood concepts in all of project management. It is the longest amount of time the project might potentially take. So if you are being safe, if you're playing it safe, and you're trying to estimate how long a project will take to accomplish, it makes sense to go big. Let's take the longest potential path that could take to get through this particular project, and that is our critical path. We can calculate it using project management software, but in this chapter we're also going to show you how to manually calculate it as well. So here we have three potential paths through a project. We've got path 1, path 2, and path 3. Well, which one is the critical path? The longest is the critical path, which is 15 days through the project. We see that we've got multiple ways we could get this project done, different steps that we could take. And the longest path through the project, the longest potential path is the critical path. That's 15 days. So let's show you how these calculations actually work. First of all, the concept of float or slack means how much wiggle room do you have in an activity without screwing up the critical path. In other words, are there tasks that we could take a little bit longer on or a little bit less time on and still stay within our intended time frame? So if you've got a task that's on the critical path, if it's on the critical path, it has no slack. If you get into the concept of free float or slack, that means how much time can you delay a specific activity without delaying the start of any activities that come after it. And total slack or total float is the total, that's the total amount of time an activity can be delayed from early start without delaying the project planned end date. So again, guys, as long as you understand that for the purposes of this class that float or slack are the amount of time that you can delay a task without screwing up your whole timeline, you're in good shape. Keep in mind, whether you're using Project Libre, or other kinds of software, some of these software packages use the term float, some use slack, some give you the options of both, so it can get very confusing. For purposes of this class, float or slack means how much wiggle room you've actually got on an activity. So how do we calculate float or slack? You can do two methods, and the reason we do two types of calculations, we verify our calculations. One is called late start versus minus early start, and late finish minus early finish. And this is where we get into the little boxes you see in the text that demonstrate how we can do this. So early start, that means the first day you could possibly get something started if everything else was going perfectly. If you're getting everything done at an early time, the earliest possible date, that is the earliest time you can start that activity is early start. Late start, same concept. And it goes from the opposite direction. What's the latest time you can start without messing up the rest of your schedule? Again, this is how we calculate our total float. And again, early finish. What's the earliest you could finish based on everything else before you going perfectly well? And late finish, what's the latest you could finish something, a task on your project list, without messing up everything that comes after it? So we break each step down. Again, we're looking back at the paths we're walking here, and we're going to try to determine the critical path. How does this work? Well, again, this is a nice little calculation box. It shows our activity duration. So we got the early start, early finish, late start, and late finish. Early start is up in the upper left corner, early finish upper right, late start lower left, and late finish lower right. And we're going to do what we refer to as a forward and backward pass on this project path. It can be a little confusing because we get into converge points. So again, early start, early finish, late start, late finish. Early start and finish are on top. Late start and late finish are on the bottom. Let's show how these combine together. All right, so we can see, for example, because we're at the beginning of the project, we're doing our first walk through. Right now, our early start is at 0 because the project has just started. Right now, path 1 is going to take us 2 days. So we go from 0 to 2 on this path. We take the secondary path, which has 2 potential paths in it. We have 0 and it goes to 4 because there's 4 days if we take this path to accomplish the project. Okay, well then we hit what we refer to as a converge point. And remember, we're calculating the critical path, the longest potential time through. So you can see here, even though we have 4 days here and 2 here, because we've got a converge point on this project, we're going to take the higher amount. We're not going to take the 2, we're going to take the 4. The higher amount and the forward pass is what goes forward for our calculations. So right now, we've gone from 0 to 2 and 0 to 4, but since 4 is the larger number and we've got a converging path, 4 comes up here. 4 goes forward on this one as well because it's the larger number. If we add 4 plus 5, or 4 plus 1, we have 5. If we have 4 plus 5, we have 9. So far this path is ending up as longer. And then the 5 carries over. We go from 5, add 10 days, we've got 15. We carry the 9, and we go 2 more days, and we've got 11. So we end with 15 and 11. Now we're getting ready to start our backward pass. Well, the first thing we're going to do is take the larger number of the 2 and move to the bottom for the backward pass. And we're going to do the math in reverse. So 15 minus 10 equals 5. 15 minus 2 equals 13. We're going to carry the 5 over. We're going to carry the 13 over. Now, when we get to this point, 5 minus 1 is 4. 13 minus 5 is 8. When you get to the converge point on the backward pass, however, you take the lowest number. So we get the 4 up top, and we take that back. And what we have at this point is a path that is consistent between all of these areas. So any of the places that don't have slack, again, are our critical path. And you can figure that out by essentially doing your calculations in each box. So if we look at the duration of each of these activities, the critical path and the amount of total slack or float carry up, because the float equation is late start minus early start, late finish minus early finish. So if we go back to the previous slide, and anytime we have a late start minus an early start, anytime we get a 0, anytime you come up with a 0, that means that you've got an activity that is part of the critical path. So anytime you have late finish minus early finish, and you have if you end up with a 0, you have a critical path. And again, the numbers where we end up with float, because we take the calculations and apply them here, the ones with 0 float are part of our critical path. In this case, B, D, and G are part of our critical path. So again, these are calculations that your project management software will do for you. And in fact, what I encourage you to do, if you're not getting the calculations correct, take a second, enter the stuff into Project Libre or Microsoft Project, and see where the critical path comes out. If you get consistency between the two, you've probably done your calculations correctly. That's what the software does for you. Again, to check your math, just for purposes of this class, if you take late start minus early start or late finish minus early finish, you again will find the activities that end up comprising your critical path. Please let me know if you have questions. I appreciate your time and attention, and I appreciate your hard work in this class. Have a great day.